In this video, we'll write the electron configuration for Te, that's tellurium. We'll also write the configuration for Te2-. So starting out, we know that we have 52 protons, that's the atomic number, and the elements on the periodic table, they're all neutral. They don't have a negative or a positive sign after them, they're neutral. The number of protons will equal the electrons. So for tellurium right here, we have 52 total electrons that we need to distribute in our electron configuration for Te. This is the electron configuration, and there are two ways that we can write this. First off, though, let's write this in a condensed form. That'll help us understand what's happening here. So I have Te here at 52, so I go to the noble gas before that, so I'll go back and here 36 Kr. So if I take 36 and put it in brackets, right here, 36, that's krypton. That's the electron configuration for krypton. So I could just write Kr and then put this after it. So this is the condensed electron configuration for Te. So one way to do this is to look at the periodic table broken up into these orbital blocks. We have 1s1, all of these are 1s2. We have our d blocks, goes up to 10, and then our p block, 2p, 3p, 4p, 5p, and p holds 1, 2, 3, 4, 5, 6. So we go down 1, 2, 3, 4, 5. We'd have 5s2, 4d10, and then 5p, 1, 2, 3, 4. So just by knowing where tellurium is on the periodic table, we know we end in 5p4, and before that we have a 4d10 and a 5s2, just like we have in our configuration here. Sometimes you'll see the 5s2 written before the 4d10. So we could figure that out and then just put krypton, Kr, before it. That would give us the electron configuration for Te. Another way would be to use the diagonal rule. So you have a chart like this where you go 1s2, 2s2, 2p6, 3s2, all the way up till you use 52 of these electrons here. And that would get you to the 4p4 right here. So this would also give you the electron configuration for Te. But let's talk about if you had the Te2- ion. What would that look like? So we consider these electrons outside this noble gas core to be valence electrons. But for this 4d10, d with 10, it's not going to be involved in bonding most likely. So we have these as our valence electrons. We have 2 plus 4, 6 valence electrons. If we could add 2 more electrons, we would end up with 5s2, 5p6. If we do that, we have Te2-. So the electron configuration for Te2-, we just added 2 more valence electrons. We end up with 5p6 is our electron configuration for the ion here, the anion. This is Dr. B with the electron configuration for Te and Te2-. Thanks for watching.